All right. This is my second time looking at this problem. I couldn't figure out a way to do this in my first try, so I look at some solutions. So I'm just going to repeat the problem. So we divide two integers without using multiplication, division, and mod operators, and it can be negative values. And we have dividend and divisor, and we have to just get rid of the fractional part as we do here. So just return the integer part. If it is negative, just return it like that. So there are some edge cases where, for instance, here, if we have it like if we have our dividend -1 or okay, 1 second, so let me think. So if our divisor is equal to 0, or if divisor is equal to 1, then if it is 1, then we just divisor is equal to 1, then we just return. If it is 0, if it is 1, I just return the dividend, right? And if it is 0, I have to return the dividend. And if the dividend is equal to 2 to the power of if the dividend is equal to 0, or if dividend is equal to 0, we just return 0, or divisor is equal to 0, right? I should have that here. And also here, if the dividend or if dividend is equal to, oops, I should just close this. If dividend is equal to 2 to the power of 31 minus 1, right? Then just we return 0. And it says, so return to the power of minus 1. Okay, so we have to know if the result is negative or positive. So for that, we just for negative values, so it will be negative if dividend, so is it positive if dividend is greater than 0, and okay, so if it's negative only if and only if they are opposite, right? So if it is, so for negative, it can be only negative if one is negative, right? Or and divisor is greater than 0, or dividend or both of them are less than 0, right? So Same thing, but it should be less than 0. Negative. So they are negative if these. So these will return true. Yeah, it is actually positive. So if these are the cases, we have a true. So false, and that will be also false. Right? Yeah. Okay. Then we have the end result is positive or negative. We know this. And at the end, like if positive, we will have a result here. But how should we handle the division? So here we'll just go over divisor. So if we multiply, let's say that we have 3 here, we multiply it by 2, which means that we shift the bits, or we add 3 plus 3, right? And by the way, when we do this, we should have dividend is equal to absolute value of dividend, and also divisor is equal to absolute value of divisor. And here now we have positive values, and we want to have a while loop while divisor is less than dividend. We have more to go, and in that case we'll just create something to hold, like a temporary variable that is holding that will be divisor. And then while, so we will keep increasing. We'll also have a current count is equal to 0. Actually, it should be at 0. So while actually it should be 1, because we will multiply it by 2. And we also have a result here, which will be 0. I'm just gonna give a 1-minute break. Right, I'm back. So here, so I want to multiply the divisor by 2. So here in this while loop, which I don't have a condition yet. So while actually the temp divisor is smaller than the dividend, which I actually have temp dividend. So dividend actually should be, wait, divisor is always same. So this is not divider, but this is actually a temp. So we have a temporary number. So we will double this every time. So if it is less than the temp dividend, it means that we just so I'll have it here. Okay, so let's have that divisor. So temp is equal to plus equal to temp. I double it. So I have 3. I double it. Now current count will be equal to current count. I'll just double that 2. I had 2 there. Now I double it. I have 2 there. Then I double it again. After that, I double it again. Right. And double this again. Now I have 6, 12, which is greater than the temporary dividend. So I'll just get back. I have to. Maybe temp plus temp. If it is smaller than that, I go in. Right, all right. So 10 plus 10 is less than 10, all right? Because divisor, we have 6. When we have 6 less than 10, we just go in, increase the count by 1. I double both of them, or I can just also shift, but that's fine. But then I will have 6 plus 6 will be 12, then I don't go in. Then I here have to, my temporary variable will be same, yeah. My temp dividend will be equal to, I just minus the temp. And why is that? Because from 10 I want to cut 6 and I will have 4, I will have 4 left, and I want to go over that again from the start. And here I also want to append the result, the current count, so that I count that at the end. And we will also stop if divisor temp dividend, it should be like this. So we have 10. This is 10. I'm just gonna, okay. All right, let's take a look at this. This is 3, 10. I have temp divisor, which will be 3, count 1. We have 6 here, we go in. Temp is now 6. Actually, this is here, like it is 6. Current is now 2. Temp dividend will be now, this will be 4. And result is 2 plus 0 will be 2. And then I'll come back here. 3 is less than 4. We go in. Temp is divisor. I have it here, temp 3. We go in. When you sum that, it is like 6 is less than 4. We don't go in. Here I decrease the temp divisor from the dividend, which will make it 1. And I also increase the current count, which will make it 1 here. I'm sorry, it will be actually making it, we are adding it, so it will be 3. So then we won't go in here, and then we just want to return result times, actually, so here if positive, then return results, else we want to return minus results, right? Okay, let's see. We have a syntax error at the start. So if divisor is 1 or divisor is 1, just return dividend. If dividend is, when do we return 0, 0, when that's 0, when that's 0. So that's okay. See if we have a 0 there, it should return 0. But if I have 0 there and this is like 3, that's working. Let's try that. And also -1 and like 222. Font 0, divisor equal 0. So okay. Okay, right. I don't even need this. So I think it's make sure that it is. I mean, the question makes sure that it is not 0. All right. So 10 minus 3. Let's take a look at that. And 1. I think it should work. Let's see. We have a problem with 1 minus 1. It should return if the divisor is 1. I guess I'm returning 0 because yeah, this should be equal to, we also want to go in, right? So 1 minus 1. Let's see. Okay, because if it is equal, we can also add 1 to it, so that works. And here my output is that, but what do I return? I don't understand this output. Oh, because okay. If result is equal to 2 to the power of 32, return 2 to the power of 32 minus 1. It's actually 31 minus 1. Now it works, but let's say that we don't have -1 there. These are some edge cases. Okay. Let's see. Again, there's a problem. Here it should be. What if we don't have this? I had unnecessary conditions there. That's why I. Okay, so yeah, what's the complexity here? Log n times we go log n because we divide it like terms. Every time we get rid of the half, now I'll also get rid of the half every time we are dividing it. So I think it should be log n because we have this, like multiplying it or something like that. So, and yeah, I think the time complexity is of log n, and the space is of 1 because we are not using anything. Okay. Yes. Let me check complexities here. Log n to the power of 2. Maybe ours might be log n to the power of 2. Actually, that might be true because this is log n and this is also log n. Yeah, I think that's correct. Log n to the power of 2 because this is log n and this is also log n. Of course, that's decreasing, but yeah, log n times log n. That's the complexity. Okay, so yeah, this is my answer. I got a bit help, but yeah, it's better than nothing.